Okay, the purpose of this video is to share some best practices. I'm gonna go ahead and draw 5 racks. So let's draw the first rack here. This rack is gonna be a 42U in height. 42U. Each U is 1.75 inches. And in this rack 1, let's call it rack 1, it's gonna be our management rack. And on this management rack, we're gonna have servers that will provide networking infrastructure services, such as Active Directory, for example, DNS, right? Another service that is common is Network Timing Protocol to synchronize the timing for your servers and storage devices and any device that is going to be on this data center. Radius for AAA, for example, to authenticate devices in your network and authorize users, right? Another thing, perhaps login server to keep perhaps and you get the idea for rack 1. Perhaps on this rack 1, perhaps instead of having just a single rack for management, perhaps you might consider to have a second rack, right? Because normally in a common data center, you're going to have also firewalls, right? And many other devices that will allow you to provide services for this data center, and also to allow devices perhaps to go to another network. So let's keep on going with these 2 racks right here for management. So let's add another rack here. It's gonna be rack 3, and let's say the rack 3 is gonna be used for the storage devices. Okay, and I'll explain later on as I start building this scenario. Let's say that we have rack number 4 over here. And rack number 4 is going to have servers running virtualization. So let's call this compute nodes or servers. And those compute nodes can run applications. For example, they can run virtual machines. What else? So let's say that you have another rack that is going to have more compute nodes. Perhaps you're going to have another cluster of compute nodes, servers, running, for example, VMware ESXi. So that way you can virtualize your servers, and that way you are able to move them from rack to rack and from one data center to another. So this is rack 4 and this is rack 5. And let's say that you're running also VMware ESXi, for example. And then let's go ahead and build another rack. And on this rack number 6, we're going to have some this to this backup solution, for example. Okay, so now that we have the racks, let's go ahead and start populating them with servers. So let's say that we have 4 servers here. For management. So let's say these are going to be management cluster, and all these talks are based on Dell Technologies. Okay, I'm just sharing what I have read and learned. And okay, and then so you have this management cluster, might be with VxRail nodes. These VxRail nodes are a collaboration between VMware and Dell hardware, and the idea of having this type of clusters is to have virtual machines running on them. Virtual machines, right? So let's say that you have, I don't know, 10 virtual machines per node, for management node. So the beauty of this is that now, instead of having physical a server for Active Directory and another maybe physical server, or maybe you're combining Active Directory and DNS into physical servers for to have some type of fault tolerance, right? Perhaps you have another dedicated server for NTP, radios, and some other application, and maybe you have another server over here for um, DHCP, for example, and some other service. So instead of having all these physical boxes that will require a plug and it's going to occupy space in the rack, you can have all these virtual machines that can have, that those services running on these virtual machines. And the beauty of this is that if one node goes down, there is mechanisms that will turn on the VM in a different node, so that way you can continue your operation. Another beauty of VMware and virtual machines is that you can move them from one rack to another. So but that is going to be coming as I progress on these best practices for building a data center networking using Dell Technologies. So on the second rack, we can have perhaps let's say that you have a firewall, right? Perhaps you have a border router, and then let's say that for the storage devices, let's say that you have some type of iSCSI share storage, and this storage device can have your gigabytes, your terabytes of disk. Perhaps you are using SSDs or flash or NVMe type of solid state devices that are pretty fast, and normally they require a fast network, and that is the purpose of this talk. So on this iSCSI SAN, perhaps you have 4 ports of 25 gig, and then for one storage processor, and then for the other storage processor you have another 4 ports of 25 gig. You get the idea. Let's say that you have another type of storage device from Dell. Let's say this is a PowerScale NAS storage that has 4 nodes, four individual nodes in a cluster, and these 4 nodes, each one has 2 ports of 25 gig, just to give you an idea. So now you have 2, 4, 6, 8 ports, right? Of 25 gig, for example, and these are file type of storage device, right? File based. It's called a network attached storage. PowerScale. Let's call it PowerScale. So let's say that you have another Dell technology called, Dell EMC technology called Unity, and the Unity storage arrays, because we're talking about storage devices, normally can do block type of storage, and it can do file as well. So each different type of storage device has its own strengths and weaknesses, and some of them have more strength than weaknesses. So you need to choose, which one is better for you and your budget. So having said that, let's go ahead to our compute server. So let's say that on this particular example, we're going to have 30 nodes. So I'm going to draw the first one, and then let's say that we have 30 servers, and each server is going to need 4 ports of 25 gig, for example. Just to keep it simple, we can have 6 ports, 8 ports, right? And these nodes are going to be running VMware ESXi, for example, and that way you can create your clusters of nodes, so that way you can move workloads, from one node to another. A VM over here that has perhaps a database, or perhaps this node right here is a web server, and then it's connecting to a repository of files, uh, and perhaps this VM is mapped to a storage device. So you get the idea. So each of these servers are going to have 25 gigabit ports, right? Because whenever you're working with virtual machines, each virtual machine is going to demand um, communication, right, to another host or to another device such as storage, or perhaps you have to go out to another network through your firewall and border router, for example. Let's say that for rack number 5 you have also 30 nodes. So this is going to be a highly dense rack as well as rack 4. So we're going to need a ton of ports here, right? So if you have 30 nodes times 2, you're going to need 60 ports. Going to one switch, for example, and 60 ports going to a second switch that I will draw in a few seconds. And that the same thing for this other highly dense rack that is going to have 30 nodes, right? So this is node 1 and this is node 30. Okay, node 1, node 30. Okay, so and then the same, we're going to need 60 ports of 25 gig going to one switch, 60 ports of 25 gig going to the other switch. So let's start labeling. These are the ports that we're going to need for these compute nodes. Let's say that for the disk to disk, Dell has a technology called data domain, and with data domain you can do this to these backups, right? So let's say that these pipes are, I don't know, 10, 25 gig. Let's do 25 gig just for sake of an example. I'm not sure if these devices are only 10 gig or 25 or 100, but that is something that you can find out online or calling Dell. But I know that these devices exist and they are really powerful. They are used by large big data media companies to do the backups disk to disk, so that way you can recover really fast instead of relying on tape. And then if you want to do this to tape, so yeah, you can also do that if you want. Let's keep it simple for now, 6 racks. So one thing that Dell Technologies offer, as well as Cisco, right, which are the two main players. Well, actually Cisco is the big player, and Dell is growing their business and with a very powerful value added switches. So on my previous videos I talk about the VLT technology, right, which is basically the industry standard is called MC lag, right, which is the multi-chassis lag that will allow you to have a couple, the demarcation line for layer 3 and layer 2, right? Layer 3 to communicate to another network, layer 2 to communicate to downstream devices that can be switches, servers. So if you watch the other two videos, you get the idea. So Cisco has a similar technology, but they call it VPC. Very, very similar. It's based on MC lag, and Dell VLT can interoperate with Cisco VPC, and but that's going to be a different video. So let's keep everything Dell for now. So let's say that I can have the main VLT spines inside rack 1 and rack 2. As a matter of fact, let's draw them right here. So that's going to be VLT spine 1, and this is going to be the second switch, which is going to be spine 2. Now these two switches need to be linked with a couple of 100 gigabit links, right? We're going to be using the Dell S5248 just for this example. It has 48 ports of 1, 10, and 25 gig, for example, and that way we can have our management nodes with 4 ports of 25, and then we can connect to this machine, and the second port going to the second. So I'm gonna draw red as the second link, right, going to the second spine, and let's draw a blue line going to the spine one, and this is how you have your dual path, right, going to these pair of switches. Now you can add the second port, right, to that in the same fashion, right. Maybe you want to destine these other two ports for iSCSI, right, connections, and that iSCSI will go to these iSCSI devices over here, so that way you can provide storage for your VM, so that way these VMs don't need to have a lot of storage. Perhaps the second port on this first management server is going to go to spine 2, so that way you can have redundancy. You can dedicate ports. Maybe this port right here is going to be for ESXi traffic. Perhaps it's going to be for VM traffic, and the other port over here can be dedicated perhaps for vSAN, or it can also be used for vMotion to be able to move a VM from rack 1 to rack 2 to rack 3, to rack 4, rack 5, and also to do backups to rack 6. So I'm gonna draw these as VLT spines, right? Let's see, let me get a different color here. Well, what I'm gonna do here, I'm gonna draw them outside the rack. Okay, so basically this is gonna be a VLT domain with two Dell switches, S5248s. And you know what? Now that I'm thinking about it, these two spines, we want to have faster ports. So let's go ahead and this is part of the thinking, right? Whenever you're designing switches that have 32 ports of 100 gigabit, each 100 gigabit port can also be run at 40 gigabit. So now the advantage of having these as spines is that you can have 100 gigabit ports for your leaves that we're gonna start adding to each of the racks to tie all these technologies together and create the network. Or we can also use it as a breakout, just in case you need to provision a firewall that has 25 gigabit ports, for example, and then you can just break a 100 gigabit port into 425s, for example, or a 40 gigabit port into 410s, 10 gigabit. So that way you have flexibility, right, to use 100 gigabit port to leaves, 25 gigabit ports to maybe firewall, perhaps 10 gigabit to some other device that is part of the management racks. Okay, having said that, we already have our top switches, right, that is going to have the demarcation line of layer 3, or the boundary, the L3, L2 boundary, and then in layer 3, of course, we can go up to Cisco switches, core, or it can go to Dell core switches, for example. It can go to routers, it can go to firewalls. We can use dynamic routing protocols such as OSPF or IBGP or EBGP, right? Depending on the use case. And this is the layer 3 dynamic routing protocols, right? And over here, that downstream, we can connect our the leaves that will go on each of the racks. So to support the downlinks to the server. So right now we put the main top switches in the topology. If you look at the other two videos, you get the idea. So let's go ahead and do the leaves for this rack 1. So let's add a couple of switches, and these two switches here, let's use a different color because it's getting a little busy, and I don't like it. So let's see if we can make sense with using a different color. So let's use green. So let's add a couple of 5248s to support the devices on this rack. So this is this Dell S5248s are going to have 48 ports of 1, 10, or 25 gig. Okay, and that way, okay, so that's going to be leaf 1, leaf 2, and then we go to the second rack, and let's go ahead. I'm going to squeeze them here. This is just notional, right? It's not perfect, and these two are going to be tied together in VLT mode. Cisco call it VPC. If we are using Cisco switches, so let's do another 5248 for this rack 2. Let's use another 5248 for rack 3 to support the storage devices. Another two 5248s. Okay, so we have now 3 sets of leaves. So for this rack that need 60 ports of 25, 48 ports is not gonna be enough. So in this case, what we do for rack 4 is that we're gonna be using the 5232s over here. We're gonna do two 5232s. These are gonna be S5248Fs. These are gonna be two S5248Fs, and these of course we already identified the two S5248Fs. So now with these 100 gigabit ports on this compute rack, we can use breakout cables, right? But that's gonna be a little bit ugly. So another solution, we can add an enclosure that is 1U in height, and this enclosure can have up to 18 modules. 2, 4, 6, 8, 10, 12, 14, 16, 18 modules of 4 ports by LC, meaning that if we have a 5232 switch with 32 ports of 100 gig, we can, for example, use an optic. We'll say a 100 gigabit SR4 optic, and then from this patch panel, I'm gonna call it a Corning patch panel that is gonna come with an MPO to MPO cable. It's gonna come with a module. Each module is gonna have 4 ports of LC, and you can have up to 18 of these modules. So that's gonna support, I think, up to 72 25 gigabit ports. So let's get the calculator and do 18 times 4. That's gonna support 72 ports, but we only need 60. So if I do 16 modules of 4, that's gonna give us 64. That's perfect. So I'm gonna use 16 modules for, I'm gonna call this leaf 1, and the same setup for leaf 2. That's the same setup. Another switch, 5232, with the optics, with the MPO cable, with the Corning 1U modules, right? The same setup. You get the idea. 18, and then in that way we can just go LC cables to the ports on the nodes, and that way is a clean installation. That way we don't have to deal with this type of breakout cables, which is a nightmare. So this is gonna be a clean solution. Let's see what else. So we're gonna do the same here. We're gonna do a couple of 5232Fs for this other node that has 30 nodes. We're gonna use the same Corning patch panels, and that way we can have clean. Well, let's draw it here. So let's say that you have another 2 Corning. These are just patch panels, and then you go off with the LCs. Make it really nice, really simple. And then for this rack over here, we're gonna use another 5248 S5248Fs, and then you have over here S5232Fs. So now to tie everything together, and that's the whole purpose, right? To build this data center network, I'm gonna use a different color. Let me see if I can use let's use orange. All right, so let's use orange. So now from the leaves, We can do a couple of links per leaf, going back to the main VLT domain, and then going from these VLT leaves, right? Oh, it has to go from the second leaf. Also has to connect to each of the. Okay, I think Okay, so then from the second leaf is gonna connect to spine one, and then to spine two, and you get the idea. Every Another thing that you have to take in consideration: what is the bandwidth for the downlinks, right? Let's say that on this server you're gonna need 1200 gigabit of aggregated bandwidth, and if you have 4 links of 100 gig going up, you're gonna have a port channel of 400 gig. So if you divide 1200 by 400, this is the down link bandwidth, and this is your up link bandwidth. Then you're gonna get a 3-to-1 oversubscription, which is not too bad. For this network, the only limitation, as on the previous videos I mentioned, is the number of ports that you have available over here at this boundary for layer 2, layer 3, the main VLT spines. There is some switches that has 32 ports of 400 gig. You can break those ports into 4 100s, so you can scale to a quite sizable data center. You can create multiple pods, or we can go and do a layer 3 closed network that can scale to thousands of physical servers. But that is another video. It's a different technology that can also be used with using whether you use Dell or Cisco. So and the good thing is that these two technologies can interoperate using industry standard protocols, right? Such as OSPF, IBGP, EBGP, and others. Let's see what else. So just to recap, one of the beauty of this design is that we have high availability. We have let's say that you had to bring down spine 1 for maintenance. You have spine 2 up, and providing a path for your switches. And then on the servers you have some ports connecting to one. Well, in this case, this VM where it's gonna connect to the leaves, not to the spine. But it's all right. So let's do it right. I hope I don't delete. Yeah, I think you get the idea. So basically, what I'm saying here is that these VMs will connect to the spines, and then these other ones are gonna connect to the other spine leaf 2. No, I'm sorry, to the leaf. Okay, leaf 1 and leaf 2, and then these leaves are gonna connect to the spines, which are over here. I hope I'm not confusing you. So basically, these two VLT spines that has the boundary for layer 2, layer 3 are gonna reside over here and over here. And I'm just trying to make it better to understand. Well, I'm trying to make it simple to understand the concept, which is the most important thing here. So the beauty of this is that if you have to go from the management server to this storage, it's only one hop. You go to the spines and down, right? If you have to go and do a backup, you can just go one hop and you are in rack 6. If, for example, you have a compute node that need to communicate with a storage device, it's going to be just one hop, right? Up and down. So that is the beauty of having some type of hierarchy, right? To have, and modularity is important. And with this design, we achieve it, because let's say that you had to bring down rack 4 for maintenance, you can migrate the VMs if you have enough storage and space on these nodes. So you can migrate the VMs from rack 4 to rack 5, for example, just in case you have that capacity, and then you can bring down rack 4 and do maintenance on the firmware. Perhaps you're gonna load a new version of VMware ESXi or your application, so that way it's modular. You can bring one rack down. The same here with this rack one. You can have some type of redundancy. Perhaps instead of having these four um, nodes in one rack, maybe you can have two over here and two over here for the management, right? Instead of having all four in one rack. So that way, if you had to bring down one of the management racks for maintenance, you still have maybe a couple firewalls, right? And everything are in a redundant fashion. So flexibility is important. Being able to use different type of workloads like compute, storage, backup, um, network infrastructure services, and this design will provide you that. Resiliency. I think I already talked about this in previous videos. This switch can go down, this link can go down, this leaf can go down, and you still have another path to the surviving devices in the network. So you can communicate east-west, going from one rack to another, or you can communicate north-south, and everything is redundant. And also in the switches you can have redundant power supplies. You can specify the airflow. Normally, if you have servers and storage, you want the ports toward the back of the rack, and or some people prefer it in the front, but normally it's on the back, toward the hot aisle. And security is also important, right? And I guess I'm gonna stop here. There is a lot of other stuff that can be considered, such as virtualizing your network, using software-defined networking, like for example VMware NSX, that you can create multi-tenancy. You can have multiple um, instances that are isolated, and you can also allow them to communicate if you desire to do so. And this is just a glimpse of things that you have to consider whenever you're building a data center network. I hope you enjoyed this presentation. Leave your comments. Tell me what is the best practices that you have implemented yourself, and let's keep these conversations going and to help each other. And thank you.